CDP and UDP. Did I say UDP? I'm sorry, I was thinking about TCP and UDP. CDP and LLDP are two important protocols in your switching environment. It works even on routers, but we are discussing on the switching environment in chapter 2. The Cisco Discovery Protocol and also the Link Layer Discovery Protocol. These two are entirely identical protocols. They are equal. Only the difference that the first one is made from Cisco by Cisco, the other one, the link layer, the LLDP protocol, is open standard, so it works on all other devices in the world. Okay, what does these two protocols do? Whatever I'm about to talk about for any one of these two is the same, can be applied the same on the other one, because both of them are identical. The only difference is the proprietary and the open standard. CDP and LDP, what it does some negotiation steps between these two devices, also these, on all your switches or routers in your networks. Each one of them using one of these protocols will know who is his neighbor, okay, or who is its neighbor. This switch will know its neighbors, this switch will know its both neighbors, also this one and this one. What will it really know? Okay, who am I connected to? It will tell you that you are using port 01, you are connected to a device of this specific model and platform, and you are using your 01 interface, you are connected to this device using maybe also 01 interface or 02 or whatever interface is it. Okay, so this will make you know specifically your interface is connected to whom and on which interface at that point. So maybe when you need to send a technician, okay, maybe to a remote site to check your device or for suspecting or troubleshooting, you will inform him that you have maybe a 3560 Cisco Catalyst switch in your site or data center, and this device has 24 interface. Interface number 1 has a cable that is extended to interface number 2 and another Cisco Catalyst switch of the model or platform 2960. Okay, so this will help your technician and will help you to understand what's happening physically in the real world, what's really happening, what are the real connections, what are the models of the devices, and how are you connected to them. Okay, so in the Cisco world, and what we will do and what you will see, the CDP protocol is used and it is enabled by default in the Cisco switches. Okay, so once you operate your switches, they are already using the CDP and negotiating. So once you issue the show CDP command, show CDP neighbor, it will inform you who are your neighbors and using which ports and their platforms. Okay, but in case if it wasn't a Cisco device, okay, then we will use the LLDP. We can enable it on because by default it's disabled on our switches, on our Cisco switches. We can enable it. I'm sorry. After enabling it, it will negotiate with any other switch from any other vendor. It might be Juniper, it might be Huawei, it might be Arista or whatever other device. Okay, using LLDP. Okay, you can also disable CDP in your entire network, no matter if it was only Cisco devices or any other devices, and enable LLDP, and that's it. So you will just apply and use only LLDP in your network, only a single discovery protocol in your network, because you know your network is built on a multi-vendor. basis. Okay, so you know that you have more than a single vendor and you want only to make one specific discovery protocol enabled, so maybe you can disable CDP, enable LLDP, since it works on both Cisco and all other vendors. Okay, so this is the usage and benefit of these two protocols. CDP and LLDP do the discovery negotiation between devices. It's automatic, you need to know nothing about it. Okay, detailed information that you can get about your neighbor. This depends on your platform and your software version, but most of them will give you your port that is connected to the opposite device, the port of the opposite device that is connected to you. You might even get the IP address and the MAC address of this neighboring device. Okay, also you will know in some platforms the port description of this other device. Okay, so you will know that in your switch 1 that is connected to switch 2, the port description of maybe fast ethernet 02 will be FA02 dash switch 1 FA01. So this is maybe the port description, so that you will know that this interface is correctly described and it's connected to you, and you also can know from your device what's the description of your device. Okay, so these are all useful information that I can obtain from the opposite device without even logging to it. Okay, so let's verify this in the lab using the pack tracer. This is the pack tracer. Okay, let's start 1 minute. Okay, so in the pack tracer we will start by using in the switches. Okay, if you can see this second last group in the switches at the corner, we will need maybe this switch. Click another switch. From the connections, automatically choose connection type. Let us have one connection between these two switches. If you would like, maybe we can have a third one, a third switch. Maybe it will be 350 60. This is another model, and 360 50. This is the third model. Okay, also let's do some connection between them and the connection this way, and let's close the ring, so we will have one I'm sorry, alternative port because of spanning tree. If you have followed us so far in the last videos of spanning tree. Okay, so what's happening right now? All these negotiations are still happening. You can be patient for some 1 or 2 minutes, or you can just fast forward. Okay, let's stop here and see that we have all our interfaces are, the first one is up, all the others are down. I think in the new pack tracer the 3560 and 3650 needs to be manually powered up. Let's have one click. This one click will show us what the front facing of the switch looks like and what the back view of the interface of the switch looks like. Okay, so there is no power button. I can't see a power button. Okay, maybe this is some zoomed in. Okay, let's extend it this way. Hope this is clear to you to see. So there is no power button in here. So maybe if I went to the CLI, no, the device is up. The device is already up, but it's behaving like switch. Maybe because it's a multi-layer switch and its version is behaving like switch, or like a router. Sorry, and routers by default have their interfaces shut it down. So we must unshut it. So first, would you like to enter the initial configuration always in routers and multi-layer switches when you face the question of would you like to enter the initial config? No, because you will configure it manually based on the needs of your network. So never use this option. Press no, press return, which is enter. Now enable show interfaces status. Let's see. Oh, now it should be clear. Okay, this is a fast Ethernet that is connected to a gigabit Ethernet, and this can't be done this way. Okay, go back. So 1 minute. This device, check the back. Okay, this is real entertainment in Backtracer. Check the back of the device, what it does. This is the front of the device. It has these interfaces. I believe these should be fast Ethernet, but maybe all of it is gigabit. Okay, these also are gigabit interfaces, copper, and these four are to be added in the future. These are SFPs. Okay, these four are SFPs, and the description here, if you can't see, it says two of them are 10 gigabit Ethernet in speed. These one are gigabit, and these two are gigabits, and these two are 10 gigabit. This is the first option. This is the first thing to notice. The second one is that in the back I have a blue port, which is the console, a yellow port for management. I have 3 fans and no power supply. So how can it work? Okay, to operate, I will click and hold on the power supply here, drag and drop in here, and this should make the device work or operate. So let's check the CLI. Oh yes, now it is booting. This maybe solve the problem, but we still will have failure, a layer 1 failure in negotiations, because it's fast Ethernet facing a gigabit. Okay, so just in case you are interested, I will do one thing. I will try to customize the gigabit interfaces and change their speed to 100 mega. Okay, so if 100 megabit works, my topology should work. Okay, always answer for no. Press another enter. Enable show interfaces. Why? Oh, because it's show interfaces status. All the interfaces are gigabit Ethernet. Yes, all the interfaces here are gigabit Ethernet. Okay, so all of them now are green, only one of them is amber. You should know why, because of spanning tree has came in. So I will do one thing. These two interfaces are gigabit Ethernet, and we must solve this by, you can see it works as 10 and 100, no problem. So it's gigabit Ethernet 101 and 102. I will configure them both in a single command. Okay, which is interfaces range. Okay, interfaces range. This will allow me to configure multiple interfaces in one command. So whatever I will do here will be applied on the interfaces that I will mention. Gigabit Ethernet. What is the common numbers? The 1 and the 1 are common. 0 and 0 are common. Only 1 and 2 here are different of the port. Okay, so I believe it was module and line card and the port number. So it's 1/0/1 and 2 this way. Okay, it should be written this way. Enter. So I'm now in the mode of config interfaces range. Okay, both of them I will do the command of maybe speed. Yes, it was speed. Good, 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 good. 100. If I typed in 100, it will force a 100 megabit per second operation. So 100, that should make it behave like a fast Ethernet. Enter. After that, exit, another exit, and now I know that all my interfaces in the topology acts as 100 megabit Ethernet of speed. Okay, so we have fixed it. Now my entire topology works. What we wanted to see is the CDP and LLDP. Now click. CDP and LLDP needs no config to start, only for the CDP, not the LLDP. Okay, so here enable, and your command will be show CDP neighbors. Hit enter. Let's check this, what it's saying. This should be enough. My switch is connected as a local interface, which is mine, from fast Ethernet 01, which is this interface. It's connected to fast Ethernet 01 of another one. So let's see if the information are uh, correct or not. Okay, platform capability. The opposite side is a switch, and the platform of the opposite side is 2960. The type of the port is a fast Ethernet and has an ID of 01. Okay, and for my fast Ethernet 02, which is this one that is connected to gigabit Ethernet 101, it is a gigabit Ethernet really, but we made it 100, but of the platform 36050. Okay, this will be, capability is not mentioned, I believe, because it's a multi-layer switch. The platform is 3650 and the port is gigabit Ethernet ID 101. Okay, so this is how to check it. But just if I wanted to do the other command, which is just change the CDP with LLDP neighbors and hit enter, LLDP is not enabled. Okay, to enable LLDP, in case you are interested, config terminal and do LLDP run. That's it. Hit enter, do end to go back to the operation, up arrow twice, show LLDP neighbor. Total entries displayed are 0 because all these switches are Cisco switches, so all of them has the LLDP disabled, so I must enable LLDP on all of them in order to check LLDP results. So let's maybe do this in here. That will make it a bit fun. Okay, show CDP neighbors. Okay, so my switch, the 36050, okay, its gigabit 102 is facing the 3560 on its interface fast Ethernet 02, okay, which is this one, and my gigabit 101, which is this interface, is facing a switch with the platform of 2960 on its port, its opposite port of fast Ethernet 02. Okay, so show LLDP neighbor, no LLDP, configure terminal, LLDP run, and enter, up arrow twice. One negotiation happened between 36050 because LLDP is now enabled on both of them, but between these two there no negotiation will happen because on 35060 we didn't enable it yet. So one entry you will find saying that my gigabit is connected to a B and B is a bridge. It's considering it as a bridge, but it's a switch. Okay, this is because of the software version of this device, and it's connected to its interface, which is fast Ethernet 02. So let's check in this device, the last one. Hit space, enter, show CDP neighbor. Okay, just the same identical results on every device. My fast Ethernet is connected to a switch with this platform on this interface. My other fast Ethernet is connected to a device which is a multi-layer switch. It didn't mention it, but the platform is clear, so good. And my gigabit. Okay, show LLDP neighbor, no LLDP, configure terminal, LLDP run, and up arrow twice. Okay, now it gave me the result between only these two devices because we haven't enabled it here, so you can enable it now. Okay, one final command I would like to check if it's available on this device, on this version. Shows the CDP neighbor, give me the question mark, there is a detail finally. So there is a detail. After the detail I can just hit enter. You can now see that I'm on multi-layer switch 1, which is 3560. It's connected to a device, okay, that is 3650 on its interface. This is my interface, this is its interface, and in here I have a lot of informations about the software version of the opposite device, all its information, the platform. This is it's using iOS XE. The version of the JPL is clear to me. Okay, and the duplex between me and him, me and this device is full, so you can see just all these information are appearing because I issued the show CDP neighbor detail. Okay, so one last command before we finish will be show LLDP neighbor, and there is a detail. Yes, there is a detail also in here. Hit enter. Okay, so what did that give us? It gave us about the same information because we issued the command in here. It gave us the chassis ID, okay, the port ID. You can check this is a MAC address. This is a lot of more information offered by the LLDP. All these information are offered by the LLDP detail command. Okay, so this is CDP and LLDP. One of them is enabled by default on Cisco because it's their I'm sorry, this their, I forgot the word. Okay, I'm sorry, sometimes the language doesn't help. Okay, just mentioned it a few minutes ago. It's their proprietary, I believe. Okay, and the other one is an open standard protocol, so you must enable it, and this is how you do it. It's either you do a run or you should shut it down if you don't want any negotiation to happen. Okay, and that's it. I hope this was informative for you. Any question, please comment below in the video, and in the upcoming video we will be very soon, okay, to finish chapter 2. So thank you for watching.